Hello, my name is Dr. Coca, and in this video we're going to be taking a melting point for a solid. So here is a solid. This is benzoic acid on a watch glass, and we're going to use also a melting point capillary. So a melting point capillary is going to have an open end, and it's going to have a closed end, and we're going to use that open end or face that open end towards the solid that we want to pick up or take a melting point of. So if we press down on the solid with the open end, it should pick up a little bit of the solid on that end. So at the moment it's right there. If we now proceed to tap on the bench, that solid will slide down towards the close end, and we can proceed to take a melting point. Now occasionally, either if the solid is wet with solvent or it has static, we might have some difficulty either putting it into the capillary or sliding it down to the close end. So in those cases, sometimes we could use one of these long rods. They're about 4 or 5 feet tall. And if we take our capillary that we have grabbed maybe some solid at the tip, we can insert it through one of the ends of this long rod and let it drop to either the floor or onto the bench, and hopefully that long drop will allow the solid to slide down to the close end. Once we have this set up, we can now take a melting point on a melt temp. So in our lab we have several types of melt temps. So this is one of the newer models. So the way this functions is we want to place our capillary through one of the ports inside of the instrument. So it's a little bit difficult to see, but basically right there we can insert up to 3 of these capillaries at any given point. And that's going to sit right in front of this eyepiece, which will allow us to observe the melting point. So in order to operate this, we want to have it obviously plugged in. And then if we turn this knob here to a setting, this will now start to heat. So this particular melt temp has this digital thermometer. So it's starting at 22 degrees, but you'll see that the temperature starts to climb ever so slowly. Eventually it increases a little bit faster, especially as we turn our knob here, our temperature control, further up. If we were to look through this eyepiece, we can see what's occurring with the solid. So initially it's going to be a solid. As the temperature climbs, eventually you'll hit the melting point and you'll be able to observe the transition between a solid to a liquid, and you can record that melting point as a temperature range, hopefully, from the time it starts to melt to the time it ends. There are other melt temps, as I mentioned, in our lab. They all essentially work the same way. So this one here is a little bit older. It has, again, also a digital thermometer. It would have an eyepiece as well here, and right behind the eyepiece is where we place our capillary tubes. We use this knob here for the temperature. So if we turn this thing on, you'll see that the light, hopefully you can see that the light turns on, and we're able to see through the eyepiece. If we turn this on here, you'll heat the solid. This is an even older model. It has a analog thermometer, and we can heat this thing up just like we would with the other ones, just have to read the thermometer instead of a digital thermometer. This is a slightly newer model, sort of the same principle. The only difference is the capillaries are inserted through the side, the eyepiece is right here, and we can control some settings on here. So this one actually has a nice feature that you can ramp up the temperature up to a specific value. So if you know the melting point of your compound, let's say it's 100, you can ramp up to about 80 degrees, and then from there slowly increase it. So you could do that with this particular model.